Math 3, Unit 3, Section 5. Today we're talking about factoring by grouping. Now, we already have learned factoring by grouping, but we're just adding a little piece that sometimes shows up, okay? So we know how when there are 4 terms, we separate them into 2 groups. We take the GCF of each group, and then now you have a GCF of the entire problem, which then factors to be your a plus b and x plus y. Sometimes when you are factoring, if you notice right here, see how this is a minus b and this is b minus a. Those are not the same thing. But we could make them the same thing by factoring out a negative. So it's like you're taking a GCF of a negative out of the problem. When you do that, you would take out a negative here, and then this B becomes a negative, and the A becomes a positive. So we're taking a GCF of a negative out. We're factoring a negative out, and then you'll notice now this problem became a negative 3y, and this flips around to be a positive A minus B. Do you now see how these are like terms? Okay, all it took was factoring out a negative. Now this would finish being factored as a minus b and 5x minus 3y. That would be the final factored form. I'm sorry, hiccups are the worst. Okay. So, next. Okay, again, look here. X minus y and y minus x. While they are similar, they are not the same. So, but we have to make them the same in order to factor out the GCF where they are like terms. When I take a negative out of this one, this negative ends up becoming a positive. And then this become a negative, and this one would become a positive. And so now this gets rewritten as a positive 7, and we can flip this around to be x minus y so that each of these are the same. Okay, so now this final factored form would end up being x minus y and 4x plus 7. Okay. You're right. 4w plus 7. Okay. So, in general and factoring, always look for a GCF first. And then remember that many expressions factor more than once. So once you factor once, check to see if it can be factored further. Starting with this first problem. If you look at the way that it has been written, you can see right here that you have 2 factors that are already the same. They've already done one step of the problem for you, basically. And so this is now my GCF, and so I'd end up writing this as perfect. Can I factor those any further? No. In order to factor something further, you would need like a perfect square. Like this would have to be x squared, or this would be x squared, and then you could maybe factor further. But since they're both just regular x's, x to the first power, they cannot be factored further, and that is my answer. Okay, next problem. Again, notice we have x plus 1 and x plus 1. Those are like terms. Our GCF is x plus 1. When I factor out the x plus 1, and just in case this isn't making sense to you guys, you know how like when we factor out a GCF, we're dividing each term by the GCF. So I'm dividing these by x plus 1. These eliminate, and you're left with the 9 minus x squared. Okay, so x plus 1 is our GCF that we're taking out. We're reducing, and we're left with what's in front here, which is our 9 minus x squared. It is okay that this is written as 9 minus x squared. If you wanted to flip everything around and factor out a negative out of the problem, you could, but This is unnecessary to do. What you have to be careful of is a lot of you want to flip these around, and you can't flip it around unless you factor out a negative. So when we're doing our differences of squares, the 3 is going to stay in front and the x is going to be in the back. Because right now the x is negative, not the 3. Does that make sense, what I'm saying? So x plus 1 can't factor further. We still have x plus 1. And this is going to factor to be what?
X plus 3.
3 minus x and 3 plus x. Either way, or you could have flipped around the plus and minuses. But make sure you keep it in the order that it is written, unless you're taking out a negative and changing things. But I didn't take out a negative here. Okay, and this is my final factored answer. Do you want to ask me any questions so far? Okay. Next one. Looking here, okay, are these the same? No. Could I make them the same?
Yes.
What would we need to do? Factor out a negative, okay? So when I factor out a negative, this 4 becomes a negative, the 2 becomes a negative, and the x becomes a positive. Okay, so when you're taking out a negative, you're just changing every single sign. Every single sign becomes the opposite. So I'm going to rewrite this, now that I factor out a negative, to be x squared, and this is still x minus 2. Instead of plus 4, though, it's going to be minus 4. And then I'm going to flip this around now to put the positive x in front, and then minus 2 at the end. Now we notice that these right here are the same, so that's my new GCF of the problem. Okay, my GCF is what? X minus 2, and I'm left with x squared minus 4. Can this be factored further?
Yes.
What piece can be factored further? X squared minus 4. Can x minus 2 be factored further? No. Okay, so x squared minus, this is a 2 squared, correct? So I'm still bringing down this x minus 2. And then x minus 2 and x plus 2, what does that factor to be? Or I just said it. X squared minus 2 squared factors to be? Right, x minus 2, x plus 2, or the other way. What do you notice about this now? Exactly. We want to, since there are 2 x minus 2's, we want to write that as one term. And so we would write that as x minus 2 squared. And then we still have x plus 2. And that is our factored form. Any questions or clarification? Okay? All right, so we're going to keep going, keep practicing. Next problem. On this one, we always want to check to see if there's a GCF of the entire problem. I usually always look at it in 2 separate pieces, meaning I look at the numbers. So this has a 9, this has a 9, this doesn't have a 9, so therefore 9 cannot be a GCF of the entire problem. Then I look at my variables, okay? So this has an x, this doesn't have an x. Therefore, I can't take an x out of the entire problem. So there is no GCF for the whole problem. Does that make sense? Okay, so because I have 4 terms, what am I going to do now? Group them. Very good. So we're going to have 2 separate groups here, our first 2 terms and our last 2 terms. And now we're just going to do the GCF of each of these groups. So what is the GCF of the first group?
9.
9. Okay, and when I factor out that 9, if you want to, you can divide each of the terms by 9 if it's easier for you to visually see things. And you reduce those, and what are you left with? X minus 1. What would be the GCF of the second group?
X squared.
X squared. And so when I divide each of these by x squared, what am I left with? 1 minus x. So remember that anytime you have 2 things that cancel out, x squared and x squared, that makes a 1. Okay? Now, are these the same?
No.
No, these are not the same yet. And so in order to make them like, what will we need to do? Very good. Factor out a negative. So when I do that, the x squared becomes negative, the 1 becomes a negative, and then the x becomes a, or the negative x becomes a positive. I'm going to go ahead and rewrite this now. So I have 9 and x minus 1 minus x squared, and I'm going to go ahead and flip this around to put the positive x in front and the minus 1 at the end. Now these are like. This is now my GCF. So we factor out our GCF, which is x minus 1. And then we're left with, in our second parenthesis, what? Very good. 9 minus x squared. Can I factor this any further? Yes. So anytime you have an x squared term in one of your factors, you want to check to see, well, is everything in that parenthesis a square? So can we write 9 as a square? Yes, 3 squared. Okay? So basically your check is just to look for a square. Okay? And then check to see if everything in that is a square. And in this case it is. So I still have x minus 1, which I keep. And then 3 squared minus x squared factors to be what? 3 minus x and 3 plus x. And you have to keep it in that order because it is the x that has a negative with it, not the 3. Yes?
You just told us we can't do that on problem 9 or 2, whatever. Oh,
Yeah.
you did do
No,
it.
she didn't do it like that.
Okay, so we're good? Okay, perfect. All right, any other questions? No? Okay, next one. Always check for a GCF out of the entire problem. So again, I'm going to start with just the numbers. Okay, this has a 4, a 12, and a 12. Therefore, what number could I factor out of the entire problem?
3. 8.
Wow.
4.
4 is correct. The rest of you are just silly. Okay, then we're going to look at our letters. This has 3 W's. This has 2 W's and a Z. So obviously Z will not be a GCF because this doesn't have a Z. Do we agree with that? So 3 W's, 2 W's, 2 W's, 1 W. So what's the most amount of W's I could take out of everything? Good.
1.
So 4W is our GCF of the problem. Are we all okay with that?
Yeah.
Okay. So we are going to go through, and if you mess up at this point, this is why I would write 4W underneath every single term so you can visually see what's happening. Okay? On the first term, the 4's cancel out, one of the W's cancels out, and you're left with what?
W squared.
Very good. Minus. Here the 4's cancel out, one of the W's cancels out, and you're left with what?
WZ.
Very good. The next term, 12 divided by 4 makes a
3.
3. 1 W cancels out, and you're just left with a
W.
W. Minus 12 divided by 4 is 3. The W's cancel out, and we're just left with a Okay. Now, it's important to know that this is still part of our answer, but it's already been factored. It's already been taken out, right? So what will be our next step now? Grouping. We're going to group inside there. Okay, what's the GCF of the first group?
W.
And what will I be left with? W minus Z. What's the GCF of the second group?
3.
What am I left with?
W minus Z.
Do these match?
Yes.
Yes. Okay, so I want you to write it in its final factored form. Okay, so So you should have had W minus Z and W plus 3. And then hopefully you didn't forget that you still have that GCF of 4W. Can any of this be factored further?
No.
Any questions there? Okay. This last one, I want you to try on your own. Check for GCF first. I mean, walking around, I would love a volunteer for someone to come up and do this one. And if you have questions, raise your hand and I'll come answer them.
You always look through here first to see is there a number of those that are in the so always look between 86, 86 to the highest number. Yeah, they have that. We're going to take 3 out of 3 and give them 3 6. Then I look at the left. This has 3 x's, 2 x's, 1 x, and no x. So I can't take out an x because this is So I'm only going to take out the GCF of 3. Okay. So like on this one, you actually can have a GCF before that. So you live in all the
Do I do that right here?
So you're going to divide each of these by 3 and write it out, yes. Well,
Because this,
basically they didn't have a number in common. 9, 9.
okay. So if they have it in parentheses, it's totally different from this.
Well, it's not totally different. What's happened here is that they have just gone to this step before you. Do you see how these actually are like the same problem?
Sure.
So it's really about the same problem. So they just started you halfway through. Okay, but it's the same thing.
All right. Anybody think they have it?
Perfect. Do you want to do it up here?
I don't have the handwriting.
Great. Good. You want to do it up here?
Numbers. My numbers are better than my actual names. The numbers on my letter are usually
Look, instead of making the
Perfect. Okay, Carrie's coming up, but I'm still going to be walking around and checking you guys.
Doing the tournament.
Me too.
Yeah.
Really?
Oh well. That really noisy.
Okay.
Noisy.
I'm just gonna like. Get it, OJ.
Don't like talk about it.
I don't like
Hey,
this.
quiet please.
Stop.
All right, so Carrie's starting by taking out the GCF. There is a GCF of 3, okay? When she looked at the x's, there wasn't an x with the 6, so you couldn't take out a variable GCF. You only have a number GCF. Okay, so when she did that, she split it into the 2 terms, even though you didn't see her split. She did split it. I'm just going to add a little to it while she's doing it. So she did these 2, and these 2 are her groups. She took out the GCF of x squared from the first group, and then a GCF of -1 from the second group. When she continued to factor, very good, perfect. Thank you. You can have a candy. So she thought that these were her like terms, which is how she factored out here, x plus 2. X squared minus 1 is a perfect square. X squared minus 1 squared. 1 is a perfect square. 1 times 1 is 1. And so that's how it factors to be the x plus 1 and x minus 1. And then she didn't forget to take out the GCF from the very beginning. Do we have any questions on this work? How many of you got it right? How many of you just forgot to not factor the x squared minus 1? Okay, so as a reminder, like a note to yourself, is that Whenever you see a square term, think about the numbers that's with it and could you make it a square? Okay, and 1 times 1 is 1. All right, I'm going to move on. Can we move on? We good? Okay. Okay, so again, we talk about this all the time, but to find the y-intercept, set x equal to 0, solve for y. To find the x-intercept, set y equal to 0, solve for x. Okay? So, and remember that when in factored form, you set each factor equal to 0 and solve for x. Okay, that's when we're drawing the lines down and setting each of our parentheses equal to 0. With every problem when we start, you want to check for a GCF of the entire problem. I start by looking at each of the numbers. So you look, there's a 2, a 6, a 2, and a 6. With all of those numbers, do they have a common factor?
Yes.
What is that?
2x squared.
A 2. Good. Then I look at the letters. X to the 5th, x to the 4th, x to the 3rd, x to the 2nd. So the largest amount of x's that I could take out would be
X squared.
x squared. Okay, so I am factoring out a GCF of 2x squared. Not all problems have a GCF, but if they do, you need to do that first. So when I divide every term by 2x squared and write that out as my GCF of the problem, we then reduce. The first term reduces and becomes what? X cubed. The next term reduces and becomes 3x squared. The next one reduces and becomes negative x. And the last one reduces and becomes negative 3. And the x squareds cancel. Are we all good with the GCF there? Okay. How many terms do I have here now? 4. We split them into our 2 groups. What is the GCF of that first group? X squared. You divide each of these by x squared, and what are you left with? X plus 3. Good. What's the GCF of the second group?
-1.
Very good. And when I divide each of these by -1, what am I left with? X plus 3. We notice that these match, correct? So the GCF now of this problem is what? X plus 3. And I'm left with x squared minus 1. And I need to not forget my GCF. Always go back and check for your GCF, which is 2x squared. Can I factor any of this further?
Yes.
Yes, because I look, there's a squared term, and then I see it's a -1, and I know that that is x squared minus 1 squared, because 1 squared is 1. So my final factored form, y equals 2x squared, x plus 3, and then x squared minus 1 squared factors to be? Very good. X minus 1, x plus 1, or vice versa. Okay, going back to these directions, it said to number 1 factor, number 2 sketch, and make sure that you label all x and y intercepts. Okay, I have factored. In order to sketch, I'm going to set each of my factors equal to 0. When I set 2x squared equal to 0, what does it equal? Very good. X equals 0. Is it going to bounce or pass? Why does it bounce? Because it's squared. It has a multiplicity of 2. This next one is going to be x equals what? -3. Pass or bounce? Pass. Why does it pass? Multiplicity of 1. Very good. Next one is going to be x equals 1. Pass or bounce? Why is it passing? Multiplicity of 1. Next one is going to be x equals -1. Pass because multiplicity of 1. Do we all understand where the multiplicity comes from? Okay. In order to fully graph, we need to know our degree, which is what? 5. You can get that from your original problem, or you can add 2 plus 1 plus 1 plus 1, which also equals 5. Okay, my leading coefficient is what? 2, and specifically we want to know that it is positive. My right-hand behavior is what? Positive infinity, because my leading coefficient is positive. My left-hand behavior is going to be because my degree is odd, and odd goes in opposite directions. Okay. We are now going to our graph. Okay, I'm going to plot these points. At 0, I make a point, and it's bouncing. Okay. At -3, I'm going to put a P for passing. At 1, I'm going to make a point and put a P for passing. And at -1, I'm going to put a point and put a P for passing. Next, I'm going to write in my end behavior. On the right side, I know I'm going to positive infinity. And on the left side, I know I'm going to negative infinity. Everything else should work out perfectly based on my information if I did it correctly. So this is passing through. It turns around, it passes through, it turns around, it bounces, which means it goes the other direction, and then it's passing through. Okay, any questions? Okay, this next problem. F of x minus g of x. This means that we take f of x, which is 2x cubed plus 6x squared, minus g of x, which is 18x plus 54. What do I have to do now? Distribute. Again, if this is saying g of x here, make sure that the whole g of x is being subtracted, which means I have to distribute the negative. Y equals 2x cubed plus 6x squared minus 18x minus 54 when I distribute through that negative. Okay. Looking at the numbers, is there a GCF? What is it? 2. Is there a GCF with the letters? No, because there's no letter here on this last term, so we can only take out a GCF of 2. So we factor out the GCF of 2, we divide each of these by 2, and we're left with x cubed plus 3x squared minus 9x minus 27. Since I have 4 terms, we are using the method factoring by grouping, which means we group the first 2 and the last 2. What is the GCF with the first group?
X squared.
Very good, x squared. And I'm left with? Very good, x plus 3 is correct. What is the GCF of the second group? -9. Since there's a negative here in front of this first term, we want to factor that negative out. We divide by -9 to each of those terms, and I'm left with x plus 3. A negative and a negative divide and make a positive. These factors match, and that is now my new GCF of this problem. So that will factor to be x plus 3, x squared minus 9. Okay, and also don't forget that we write the 2 there in front. I always want to check squared terms to see if they can be factored further. Can this one be factored further?
Yes.
Yes. X squared minus 3 squared. 9 can be written as 3 squared. So, x squared minus 3 squared factors to be x minus 3, x plus 3. Correct? We also notice that there are 2 x plus 3s, so I want to write that as what? So we have final factor form. Y equals 2 and then x plus 3 squared and an x minus 3. And that is x plus 3 squared because there were 2 of the same factors. Okay, I'm going to keep going. Are we good? Okay, so to graph, we're going to set each of our factors equal to 0. When I set 2 equal to 0, does that even make sense? No, that's out. X plus 3 equal to 0 makes x equal, and will it be a pass or a bounce? Bounce because multiplicity of 2. This one will be x equals 3, pass or bounce, because it has a multiplicity of 1. What is the degree for this problem? 3. What is my leading coefficient? 2, or just positive. Okay, because the leading coefficient is positive, my right end behavior goes to positive infinity. My left end behavior will be negative infinity because it's an odd degree. We go and mark these. There is a point at -3 that bounces. There is a point at 3 that passes through. And I notice I do not have a y-intercept. How do I find it? Plug in 0 for x, solve for y. Okay? If you go back to this original problem, you can do it at any point. This is, right here, is really the easiest, right here. This will make a 0. This will make a 0. This will make a 0, and this makes a, what's my y-intercept? So I'm just going to put here, y-intercept is 0 for x, -54 for y. So I'm going to mark on here. This is how I'm labeling my y-intercept. -54. That's my label. Okay. Right end behavior, positive infinity. Left end behavior is negative infinity. This passes through, touches here, bounces, and we are done.